Welcome to the session Successive Differentiation. Definition and notation. The derivative of a function f of x with respect to the variable x is a function f dash x whose value is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x all divided by h provided the limit exits. The domain of f dash, the set of points in the domain of f for which the limit exits, may be smaller than the domain of f. If f dash of x exits, we say that f has a derivative or f is differentiable at x. If the derivative f dash x has been found, we may proceed to differentiate a second time obtaining f double dash of x. This expression is called the second differential coefficient or second derivative of f. We may then differentiate again and obtain the third differential coefficient and so on up to the nth differential coefficients. This process of differentiation is called the successive differentiation. The most widely used notations for the first, second, third, etc. nth derivatives of the function y is equal to f of x are the following: dy by dx, d square y by dx square, d cube y by dx cube, etc. d raised to n y by dx raised to n, dy, d square y, d cube y, etc. d raised to n y, y1, y2, y3, etc. yn, y dash, y double dash, y triple dash, etc. y raised to n, f dash, f double dash, f triple dash, etc. f raised to n. Example 1. If y is equal to log x divided by x, show that d square y by dx square is equal to 2 log x minus 3 divided by x cube. Solution. We have dy by dx is equal to x into 1 by x minus log x into 1 all divided by x square, which is equal to 1 minus log x all divided by x square. Therefore, d square y by dx square is equal to x square into minus 1 by x minus 1 minus log x into 2x all divided by x raised to 4, which is equal to 2 log x minus 3 all divided by x cube. Example 2. If y is equal to a cos nx plus b sin nx, prove that d square y by dx square plus n square y is equal to 0. Solution. We have y is equal to a cos nx plus b sin nx. Differentiating with respect to x twice in succession, we obtain dy by dx is equal to minus na sin nx plus nb cos nx. d square y by dx square is equal to minus n square a cos nx minus n square b sin nx, which is equal to minus n square into a cos nx plus b sin nx, which is equal to n square y. Therefore, d square y by dx square plus n square y is equal to 0. Example 3. If x is equal to cos theta, y is equal to cos n theta, where n is an integer greater than 1, prove that 1 minus x square into d square y by dx square minus x into dy by dx plus n square y is equal to 0. Solution. We have x is equal to cos theta and y is equal to cos n theta. Therefore, dx by d theta is equal to minus sin theta and dy by d theta is equal to minus n sin n theta. Hence, dy by dx is equal to n into sin n theta divided by sin theta, which is equal to n into square root of 1 minus y square divided by square root of 1 minus x square. That is, square root of 1 minus x square into dy by dx is equal to n into square root of 1 minus y square. Squaring on both sides, we obtain 1 minus x square whole square into dy by dx whole square is equal to n square into 1 minus y square. Differentiating both sides with respect to x, we get 1 minus x square into 2 dy by dx into d square y by dx square minus 2x into dy by dx whole square, which is equal to minus 2 n square y dy by dx. Cancelling the common factor 2 into dy by dx and adjusting, we get 1 minus x square into d square y by dx square minus x into dy by dx plus n square y is equal to 0. Nth derivatives. Standard results. First one, nth derivative of e raised to ax. Let y is equal to e raised to ax, then y1 is equal to a into e raised to ax, y2 is equal to a square into e raised to ax, y3 is equal to a cube into e raised to ax. Proceeding like this, we obtain yn is equal to a raised to n into e raised to ax. Note, in the above result, if y is equal to a raised to x, then yn is equal to log a all raised to n into a raised to x. Second one, nth derivative of ax plus b all raised to m. Let y is equal to ax plus b all raised to m. Then y1 is equal to m into ax plus b all raised to m minus 1. y2 is equal to m into m minus 1 into a square into ax plus b all raised to m minus 2. y3 is equal to m into m minus 1 into m minus 2 into a cube into ax plus b raised to m minus 3. Proceeding like this, we obtain yn is equal to m into m minus 1 into m minus 2 into etc. into m minus n plus 1 into a raised to n into ax plus b all raised to m minus n. Note, if m is equal to n in the above result, we get y is equal to ax plus b all raised to n and yn is equal to a raised to n into n factorial. Third one, nth derivative of 1 divided by ax plus b. Let y is equal to 1 divided by ax plus b, which is equal to ax plus b all raised to minus 1. Then y1 is equal to minus 1 into ax plus b all raised to minus 2. y2 is equal to minus 1 into minus 2 into a square into ax plus b all raised to minus 3. Proceeding like this, we get yn is equal to minus 1 into minus 2 into minus 3 into etc. into minus n into a raised to n into ax plus b all raised to minus of n plus 1. That is, yn is equal to minus 1 raised to n, a raised to n into n factorial divided by ax plus b all raised to n plus 1. Fourth one, nth derivative of log ax plus b. Let y is equal to log ax plus b. Then proceed as in the above cases, we obtain the nth derivative as yn is equal to minus 1 raised to n minus 1, a raised to n into n minus 1 factorial all divided by ax plus b all raised to n. Fifth one, nth derivative of sin ax plus b and cos ax plus b. Let y is equal to sin ax plus b, then y1 is equal to a into cos ax plus b, which is equal to a into sin ax plus b plus pi by 2. y2 is equal to a square into cos ax plus b plus pi by 2, which is equal to a square into sin ax plus b plus 2 times pi by 2. Proceeding like this, we have yn is equal to a raised to n into cos ax plus b plus n into pi by 2, which is equal to a raised to n into sin ax plus b plus n pi by 2. Similarly, for y is equal to cos ax plus b, the nth derivative is yn is equal to a raised to n into cos ax plus b plus n pi by 2. Sixth one, nth derivative of e raised to ax into sin bx plus c and e raised to ax into cos bx plus c. Let y is equal to e raised to ax into sin bx plus c. Then y1 is equal to a e raised to ax into sin bx plus c plus b e raised to ax into cos bx plus c, which is equal to e raised to ax into a sin bx plus c plus b cos bx plus c. In the above, put a equal to r cos theta and b equal to r sin theta, so that r is equal to a square plus b square whole raised to 1 by 2, theta is equal to tan inverse of b by a. Therefore, y1 is equal to e raised to ax into r cos theta sin bx plus c plus r sin theta cos bx plus c. That is, y1 is equal to r e raised to ax into sin bx plus c plus theta. Similarly, y2 is equal to r square into e raised to ax sin bx plus c plus 2 theta. In general, yn is equal to r raised to n into e raised to ax sin bx plus c plus n theta. That is, yn is equal to a square plus b square all raised to n by 2 e raised to ax sin bx plus c plus n tan inverse of b by a. Similarly, for y is equal to e raised to ax into cos bx plus c, the nth derivative is yn is equal to a square plus b square whole raised to n by 2 e raised to ax cos bx plus c plus n tan inverse of b by a. Nth derivatives of rational algebraic functions. For finding the nth derivative of a fraction whose numerator and denominator are both rational integral algebraic fractions, the given fraction must be decomposed into its partial fractions. Example 4. Find the nth derivative of 10x minus 21 all divided by 2x minus 3 into 2x plus 5. Solution. Let 10x minus 21 all divided by 2x minus 3 into 2x plus 5 is equal to a divided by 2x minus 3 plus b divided by 2x plus 5. Therefore, 10x minus 21 is equal to a into 2x plus 5 plus b into 2x minus 3. Equating the coefficients of like terms on both sides, we have 2a plus 2b is equal to 10 and 5a minus 3b is equal to minus 21. Solving, we get a is equal to minus 3 by 4 and b is equal to 23 divided by 4. Therefore, 10x minus 21 all divided by 2x minus 3 into 2x plus 5 is equal to minus 3 by 4 into 1 by 2x minus 3 plus 23 by 4 into 1 by 2x plus 5. Hence, the nth derivative d raised to n of 10x minus 21 divided by 2x minus 3 into 2x plus 5 is equal to minus 3 by 4 into minus 1 raised to n 2 raised to n factorial divided by 2x minus 3 all raised to n plus 1 plus 23 by 4 into minus 1 raised to n 2 raised to n factorial divided by 2x plus 5, which is equal to minus 1 raised to n into 2 raised to n minus 2 into n factorial into 23 divided by 2x plus 5 all raised to n plus 1 minus 3 divided by 2x minus 3 all raised to n plus 1. Nth derivatives of powers of sines and cosines. By trigonometric transformations, it is possible to break up products of powers of sines and cosines into a sum of the sines and cosines of multiple angles and hence to find their nth derivatives. Example 5. Find the nth derivative of cos cube x. Solution. We have cos 3x is equal to 4 cos cube x minus 3 cos x. Therefore, cos cube x is equal to 1 by 4 into cos 3x plus 3 by 4 into cos x. Hence, the nth derivative d raised to n of cos cube x is equal to 1 by 4 into 3 raised to n into cos 3x plus n pi by 2 plus 3 by 4 into cos x plus n pi by 2. Leibniz theorem. Nth derivative of the product of two functions. Statement. If u and v be any two functions of x, then the nth derivative of the product d raised to n of uv is equal to unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus etc. plus ncr un minus r vr plus etc. uvn, where capital D is equal to d by dx and the suffixes denote the order of the derivatives of u and v. Proof. This theorem may be proved by mathematical induction as shown below. We have derivative of u into v is equal to d by dx of u into v, which is equal to du by dx into v plus u into dv by dx, which is equal to u1 v plus uv1, which is equal to u1 v plus 1 c1 uv1. d square uv is equal to d of uv, which is equal to d of u1 v plus uv1, which is equal to d of u1 v plus d of uv1, which is equal to u2 v plus 2 u1 v1 plus uv2, which is equal to u2 v plus 2 c1 u1 v1 plus uv2. Thus, we see that the theorem is true for n is equal to 1 and n is equal to 2. Next, let us suppose that the theorem is true for a particular value m of n. Then, the mth derivative of u into v is equal to um v plus mc1 um minus 1 v1 plus mc2 um minus 2 v2 plus etc. mcr minus 1 um minus r plus 1 vr minus 1 plus mcr um minus r vr plus etc. plus uvm. Differentiating both sides of the above, once again we get the m plus 1th derivative d raised to m plus 1 of u into v is equal to um plus 1 v plus um v1 plus mc1 into um v1 plus um minus 1 v2 plus mc2 into um minus 1 v2 plus um minus 2 v3 plus etc. plus mcr minus 1 into um minus r plus 2 vr minus 1 plus um minus r plus 1 vr plus mcr into um minus r plus 1 vr plus um minus r vr plus 1 plus etc. plus u1 vm plus uvm plus 1, which is equal to um plus 1 v plus 1 plus mc1 into um v1 plus mc1 plus mc2 into um minus 1 v2 plus etc. plus mcr minus 1 plus mcr into um minus r plus 1 vr plus etc. plus uvm plus 1. But we know that ncr plus ncr plus 1 is equal to n plus 1 cr plus 1. Therefore, 1 plus mc1 is equal to mc0 plus mc1 is equal to m plus 1 c1, mc1 plus mc2 is equal to m plus 1 c2, etc. mcr minus 1 plus mcr is equal to m plus 1 cr, and so on. Therefore, the m plus 1th derivative d raised to m plus 1 of u into v is equal to um plus 1 v plus m plus 1 c1 um v1 plus m plus 1 c2 um minus 1 v2 plus etc. plus m plus 1 cr um minus r minus 1 vr plus etc. plus uvm plus 1. Hence, if the theorem is true for any particular value m of n, it is true for the next higher value m plus 1. We have already seen that the theorem is true for n is equal to 1 and n is equal to 2. Therefore, it must be true for n is equal to 2 plus 1 is equal to 3 and for n is equal to 3 plus 1 is equal to 4 and so on. Hence, for every positive integral value of n, the theorem is true. This completes the proof. Example 6. Find the nth derivative of x square into e raised to 3x. Solution. In problem of this kind, where there are small integral powers of x as one of the factors of the given product, it is always convenient to take that as second factor. Since its differential coefficients and hence the series representing the nth derivative of the product will consist of only a few terms. The nth derivative d raised to n of x square e raised to 3x is equal to d raised to n of e raised to 3x into x square, which is equal to d raised to n of e raised to 3x into x square plus nc1 d raised to n minus 1 e raised to 3x into d of x square plus nc2 d raised to n minus 2 of e raised to 3x into d square of x square, which is equal to 3 raised to n into e raised to 3x into x square plus n into 3 raised to n minus 1 into e raised to 3x into 2x plus 1 by 2 into n minus 1 into 3 raised to n minus 2 into e raised to 3x into 2, which is equal to 3 raised to n minus 2 into e raised to 3x into 9x square plus 6nx plus 1 by 2 n into n minus 1. Example 7. If y is equal to cos m sin inverse x, prove that 1 minus x square into y n plus 2 minus 2n plus 1 into x y n plus 1 plus m square minus n square into y n is equal to 0. Solution. Given that y is equal to cos m sin inverse x, differentiating both sides with respect to x, we get dy by dx is equal to minus sin m sin inverse x into m into 1 divided by root of 1 minus x square, that is square root of 1 minus x square into dy by dx is equal to minus m sin inverse x. Differentiating both sides once again with respect to x, we get square root of 1 minus x square into d square y by dx square minus x by square root of 1 minus x square into dy by dx is equal to minus m into cos m sin inverse x into m into 1 divided by square root of 1 minus x square. Multiplying throughout by square root of 1 minus x square, we obtain 1 minus x square into d square y by dx square minus x dy by dx is equal to minus m square into cos m sin inverse x into m is equal to m square y. Therefore, 1 minus x square into y2 minus x y1 plus m square y is equal to 0. Differentiating n times each term by Leibniz theorem, we have 1 minus x square into yn plus 2 plus n into minus 2x into yn plus 1 plus 1 by 2 n into n minus 1 into minus 2 yn minus of x yn plus 2 plus n into 1 into yn plus m square yn is equal to 0. That is 1 minus x square into yn plus 2 minus of 2n plus 1 x yn plus 1 plus m square minus n square into yn is equal to 0. Now, let me summarize the major points of this session. The process of differentiating a function again and again is called the successive differentiation. The nth derivative of e raised to x is a raised to n into e raised to ax. The nth derivative of ax plus b all raised to m is m into m minus 1 into m minus 2 into etc. m minus n plus 1 into a raised to n into ax plus b all raised to m minus n. The nth derivative of 1 by ax plus b is minus 1 raised to n a raised to n into n factorial all divided by ax plus b all raised to n plus 1. The nth derivative of log ax plus b is minus 1 raised to n minus 1 a raised to n minus 1 factorial divided by ax plus b all raised to n. The nth derivative of sin ax plus b is a raised to n into sin ax plus b plus n pi by 2. The nth derivative of cos ax plus b is a raised to n into cos ax plus b plus n pi by 2. The nth derivative of e raised to ax into sin bx plus c is a square plus b square all raised to n by 2 e raised to ax sin bx plus c plus n tan inverse of b by a. The nth derivative of e raised to x into cos bx plus c is a square plus b square all raised to n by 2 e raised to x cos bx plus c plus n tan inverse of b by a. Leibniz theorem states that if u and v be any two functions of x, then the nth derivative of the product u into v, that is d raised to n of uv is equal to un v plus n c1 un minus 1 v1 plus n c2 un minus 2 v2 plus etc. plus ncr un minus r vr plus etc. plus uvn, where capital D is equal to d by dx and the suffixes denote the order of the derivatives of u and v. Now, you can try to answer the following questions. First one, find the third differential coefficient of x square log x. Second one, find the nth differential coefficient of e raised to 2x into sin 2x into cos x. Third one, use Leibniz theorem to find the nth derivative of 1 minus x square into sin 2x. And the last one, if y is equal to sin inverse x whole square, prove that 1 minus x square into y2 minus x y1 minus 2 is equal to 0. Also deduce that 1 minus x square into yn plus 2 minus of 2n plus 1 x yn plus 1 minus n square yn is equal to 0. For your further study, you can refer the following books. First one, Differential Calculus by Shanti Narayanan, Sultan Chand and Company, New Delhi, 2003. Second one, Differential and Integral Calculus by N. Piskunov, Peace Publishers, Moscow. Third one, Calculus, 9th edition by George B. Thomas, Rosal Finney, Pearson's Education, New Delhi, 2002. Hope that you have enjoyed this session. We will meet again with another topic. Thank you.